Humans have always gazed at the sky, slowly transforming myths into science. For the vast majority of human history, our understanding of the cosmos was limited to what we could see with the naked eye. The sun was a source of warmth and light, the moon, a celestial timekeeper, and stars were these seemingly fixed points of light, grouped into constellations given mythological significance, leading to the zodiac. Among these fixed stars, a handful of wanderers were observed: Mercury, Venus, Mars, Jupiter, and Saturn. The Greeks called them planetes, or wanderers, and their erratic movements against the backdrop of the stars presented a profound puzzle. To explain this, ancient Greek philosophers like Plato and Aristotle conceived of a geocentric model where the Earth sat at the center of the universe, and everything else, the sun, moon, planets, and a celestial sphere of stars, revolved around it in perfect circles. This model, later mathematically refined by Ptolemy, dominated the Western thought for over 1,400 years. The 16th and 17th centuries saw a dramatic shift in our cosmic perspective. In 1543, Polish astronomer Nicholas Copernicus proposed a heliocentric model where the Earth and other planets revolved around the Sun. Copernicus's ideas were initially met with resistance, but they laid the groundwork for future astronomers. Johannes Kepler, a German mathematician, discovered that planets moved not in perfect circles but in elliptical orbits, a discovery that greatly improved the predictive power of the heliocentric model. To look further, we needed new eyes. Galileo built them. The invention of telescope in the early 1600s was a turning point. He saw that the moon had mountains and craters, that Venus went through phases like the moon, and discovered 4 moons orbiting Jupiter, proving that not everything in the sky revolved around Earth. The universe was suddenly a much more complex and dynamic place. Then in 1687, Isaac Newton published Principia Mathematica, introducing universal gravity and showing how the sun's gravity governs planetary orbits. Newton's laws unified terrestrial and celestial mechanics under a single, elegant framework. The 18th and 19th centuries saw the continued expansion of our known solar system. In 1781, William Herschel discovered Uranus, the first planet to be found using a telescope. The discovery of Neptune in 1846 was a triumph of theoretical astronomy. Its existence was predicted based on irregularities in Uranus's orbit. The vast expanse between Mars and Jupiter was also found to be populated by a multitude of rocky bodies, the asteroid belt. Simultaneously, the development of spectroscopy gave birth to astrophysics. It is the study of the radiated electromagnetic spectrum to reveal properties of matter. Now we had electromagnetic waves other than just visible light to tell us about what's happening out there. The 20th century witnessed an explosion in our understanding of the universe. Albert Einstein's theory of general relativity, published in 1915, provided a new framework for understanding gravity as the curvature of space-time, a concept that would be crucial for understanding the large-scale structure of the cosmos. In the 1920s, Edwin Hubble's observations with the powerful Hooker telescope on Mount Wilson revealed the existence of distant galaxies, vast collections of stars like our own Milky Way, and that these galaxies were all moving away from us. This was the first observational evidence for the expansion of the universe, which led to the Big Bang model of the universe's origin. Later in 1930, Pluto was discovered at the edge of our solar system, later reclassified as a dwarf planet. The launch of the Soviet satellite Sputnik 1 in 1957 ushered in the space age, unleashing a torrent of direct exploration. We were no longer just observers from Earth, but active explorers of the cosmos. This era saw monumental achievements, including Yuri Gagarin becoming the first human in space in 1961 and the Apollo 11 moon landing in 1969. Robotic probes were sent to journey our solar system, revealing a stunning diversity of worlds, from the volcanic plains of Mars to the icy moons of Jupiter and the majestic rings of Saturn. Modern astronomy blossomed when we decided to put the telescopes in space. In 1990, NASA launched the Hubble Space Telescope. Above Earth's atmosphere, Hubble captured exquisitely sharp views of planets and galaxies. Its most famous image, the Hubble Deep Field, peered into an almost empty patch of sky and revealed thousands of faint galaxies. some seen as they were billions of years ago. This one image showed the immense richness of the distant universe. Humans now live and work in space. Since 2000, the International Space Station has been continuously crewed, demonstrating our foothold in orbit. In 2015, the monumental LIGO experiment detected gravitational waves, ripples in spacetime from colliding black holes, opening a completely new way to observe the cosmos, as unlike electromagnetic waves, gravitational waves travel uninhibited through space. In 2019, the Event Horizon Telescope collaboration produced the first image of a black hole's shadow, confirming predictions of general relativity. While we know more about what's out there than ever before, the universe still brims with mystery. We're on the cusp of understanding cosmic puzzles like dark matter, finding new worlds beyond our solar system, and perhaps even setting foot on one. Our journey from believing the Earth was the center of everything to building rockets for inhabiting Mars has been nothing short of extraordinary. It's a testament to our most defining trait, unrelenting curiosity. For in a vast and silent universe, what greater purpose is there than to explore, to question, and to understand?